You know, doing a test like this can be very difficult, so Harv and I decided to take a couple of criteria into consideration to reduce the variables into getting the best results after the test is over. So, first of all, first criteria, we're going to change gears between 2,500 to 3,000 RPM, try to get to top gear as quick as we can, and to reach 100 kilometers an hour as fast as we can. Second of all, we're going to try and maintain a distance between 1 to 2 car lengths so that we get the same speed when we go. Third of all, being in Malaysia, we all know that it's hot, it's always humid, and it's not so good for the VO, right? So we're going to do it in nice Malaysian style, air conditioning all the way. And we all know that driving in an air conditioning car does increase your fuel consumption. Best part of it all, I am in a Civic Type R, and check it out, I am going only 100 kilometers an hour.
Nitrogen is also supposed to keep your tire temperature constant, but maybe we didn't ride the cars hard enough.
So, what do you get?
46, you?
Same. It's the same. Yeah.
No difference at all. Busted.
Yeah. One theory out the window. Next, to determine fuel consumption, we refill the cars to the brim once more and we'll measure the difference between nitrogen and air over a distance of 110 kilometers. Not bad, 8.115 liters. What's yours?
7.8.
300 ml? That's less than a can of soda.
Disappointing. Maybe we should have driven harder and gone further.
Maybe we should.
Now, the second round of the test, the performance test. First up, nitrogen tires.
Racing teams prefer nitrogen gas because it contains no moisture, resulting in constant tire pressure and quicker lap times.
Since we need to use the same driver to reduce the variables, Harv has kindly offered to be the solo driver and take both cars out for 3 hot laps each, and the times are averaged to give as accurate a reading as possible.
Now let's take out the air-inflated tires and see if there's a difference with performance.
It is also said that with nitrogen, you can improve handling. But to be honest, I can't feel any difference. However, nitrogen molecules are larger than oxygens, so they tend to stay in your tire for a much longer time. With conventional air, you lose up to 1.5 psi in a month. But with nitrogen, on the other hand, you only lose the same amount in 6 months.
Well, it looks like on average, the nitrogen-inflated tires crosses the finish line at 0.8 of a second faster. In a real race, that could mean the difference between a podium finish